All right, a plumber needs to cut a 16-foot pipe into two pieces. So what I did is the first thing I did was just draw a diagram of the 16-foot pipe. So we know the total length of this thing is 16 feet. And I want to define like a shorter piece and a longer piece. So I'll just call X the shorter piece and Y the longer piece. So the second step is to come up with our system of equations. And I'm looking for relationships that tie these variables together. And the first one I can think of as the longer piece is to be 1 foot longer than twice the shorter piece. So that's a breadth relationship. So the longer piece is, so I got Y, which is my longer piece, is 1 foot longer than, so I'm going to add 1, then twice the shorter piece. So twice the shorter piece would be 2x. All right, the next equation comes from knowing that the two pieces together must be 16 feet. So if I take and add the two pieces together, I should get 16 feet. So the two pieces are just x plus y. All right, so there's our system. And now we just want to go through and solve. So this is actually kind of nice. We can take our expression for y and substitute it into the second equation. So we can solve using substitution, and we get x plus the expression for y is 2x plus 1. And that's supposed to equal 16. All right, so here's our substitution. So we start solving, we'll combine like terms, we get 3x, and we'll subtract 1 from both sides. We get 3x equals 15. And then canceling the factor of 3 or dividing by 3, we get x equals 5. So as soon as I get x equal to 5, I want to back substitute to solve for y. And it looks like I get y equals 2 times x, or 2 times our x is 5, plus 1. So it looks like y equals 10 plus 1, or y equals 11. So after we solve, we want to go through now and answer the question. So 4, what's the answer? Well, x and y represented the length of each piece. So we can basically answer the pieces are 5, and the units would be in feet, and the other is 11 feet. We want to make sure we answer in terms of the question. All right, this next question is talking about complementary angles, and if you notice, our first step is basically done. So the diagram here is talking about complementary angles, and one thing we notice that complementary angles, if we add them up, complementary angles add up or sum to 90 degrees. So what's nice about this is that our system then uses that relationship. I know that if I take x and y and add them together, I'm going to get 90 degrees. So x plus y is 90 because they're complementary. Now the other relationship that we're going to use is this one that stated the difference of the measure of two complementary angles is 64. So if I subtract the two angles, I should get 64. So if I take one of the angles and subtract the other, I should get 64. So our system is kind of nice because we know they're complementary, and then we're given a relationship that's for the other equation. So to solve this, we can use the elimination method because we have opposite terms. So if we solve this by just adding, the left side would be 2x, and the right side, if I add that, would be 154. So solving for x, dividing by 2, it looks like we're getting x equals 77. So if we take that and back substitute, we can just substitute back in for x is 77. And then we're going to add y to get 90. So if I subtract 77 from both sides, I'm going to get y equals 13. So again, once we have our answer, we can go back and answer the question. So it says find the measure of each angle. So we can say the angles are 77 degrees and 13 degrees. Okay, for this problem, we're talking about a rectangular dog pen. If the length of the dog run is 10 feet longer than the width, find the length and width of the area that is enclosed for the pen. So the first thing I'm going to do is kind of draw a rectangular dog pen, and I don't know what the dimensions are yet, but I'm looking for the length and width. So I'll call this one the width this side and the length this side. And this is supposed to be rectangular. I was a little shaky there, I guess. So what do we know, or how can we write our system with what's given? So the second step is our system. Well, one of the things that we could do is that we know the length of the dog run is 10 feet longer than the width. So that's a direct relationship. And if we do that, the length of the dog run is to be 10 feet longer than the width. So the length, which is L, is supposed to be 10 feet longer. So I'm going to add 10 to the width. So that's one of the relationships. And then the other relationship comes from the idea that the wants to make a rectangle with 28 feet of fencing, and the 28 feet of fencing means that the perimeter is 28 feet. So the perimeter, we have a formula 2L plus 2W equals 28. So that's going to be our equation. The perimeter takes twice the length and twice the width, and that would be the total distance around. So this would be 2 times L plus 2W is supposed to equal 28. All right, so solving. This one's kind of nice because L is already solved in the first equation. So I'm going to take this W plus 10 expression and plug it into the second equation for L. So the substitution would give me 2 times L, which is the expression W plus 10. Then the rest of it is plus 2W equals 28. So solving this equation, distributing, we have 2W plus 20 plus 2W equals 28. 2W and 2W is 4W. And if we subtract 20 from both sides, we get 8. So getting rid of the 4, canceling the 4, dividing by 4, it looks we get W equals 2. So if we back substitute, we get L then equals 2 plus 10, or L equals 12. So I'm just going to come back here, and the answer, well, it says find the length and the width of the area that is enclosed. So the width, or the length, is, and that was L, that was 12 feet, and the width is 2 feet.